1.3 and 1.4, I'm going to put these two together because they both are regarding slope. Slope is a really big and very important task when it comes to graphing, something that's very important to remember. So this one might go a little bit long, but the information in this is very important. So slope, what is slope? The definition of slope is the steepness of a line. So slope is kind of the vocabulary word for your note to self. And you just want to look at these lines and say, okay, what is the steepness of this line? What is the steepness of this line, and this line? I think about a skier. If a skier were skiing down this hill, down this hill, down this hill, down this hill, what would be, what would it be rated? Would it be a blue or a green or a black, depending on how difficult it is? So mathematicians like to put a number on it, as you would assume, and they are basically talking about the rate of change within the values. Remember, we talked about in the last section how there are infinite points along this line that satisfy an equation. Well, we're going to get into linking the line to the equation in the next chapter. But right now we want to figure out, okay, well, what is the rate of change of this line if I just look at it? So the slope of this line versus the slope of this line is going to be that this one is less steep than this one. So the number on this one's going to be less than the number on this one. So this one happens to be a slope of 1, 2, 3, 4. The slope on this one happens to be 1/4. The slope on this one happens to be 6, I believe. So I'll get into how to compute that in a moment, but I just want to show you that this is a fractional slope and this is a whole number slope. The greater the number, the steeper the slope. The other way to look at it is that these are, when you read them like a book from left to right, these are going in an upward direction. They are rising, so their slope is positive. This slope, if you read it from left to right, is declining, so that's going to be a negative slope. The number will be similar to the number is when it's positive, however, going in a downward fashion is going to be a negative slope. This slope is negative 1, 2, 1, 2, 3. It's negative 2/3 this slope. And this slope here is that how much is it going up or down? It's not going up or down at all, so the slope here is 0. And we will get into how to compute these on the next page. But I just wanted you to get a general sense of the steeper the line, the greater the number. No slope at all is going to be 0 because it's just flat. And going in a downward direction rather than an upward direction is going to give you a negative slope. So this is how we compute slope. This is a very important thing to put in your notes to self also. Slope is rise over run, which is the one I'm mostly going to talk about on this page. Okay? This other one comes into play in the next page. So rise over run. So I'm going to find 2 points on my line. And you have to be very careful to find points that actually cross 2 blue lines. So if I were to look at this one, let's say this one crosses 2 blue lines. And this one here. So if I want to find the connection, and you can find any points along this line, but you want to find ones that hit right at an intersection of 2 of the blue lines on your graph paper. Because I don't want to choose one in the middle. That's not going to be helpful for me because it's going to be fractional and I have to estimate. So if I'm going to do a rise over run, I'm going to figure out how do I travel from this point to this point along the blue lines. So I have to go up and I have to go over. Well, just how many boxes did I go up? 1, 2, 3. I went up 3 boxes. Well, that's a rise of 3. Then I have a run of how many? 1, 2, 3, 4, 5. I have a run of 5. So my slope on this line, 3/5. It should continue the pattern. So you should check yourself by saying, okay, if I travel rise 3, run 5, I should hit another point. And I do. It also, if I had traveled, I'll use a different color. If I had traveled from this point to this point, I would have risen 6 and run 10. I would have gotten 6 over 10. Well, guess what? When you reduce that fraction, you actually take out a factor of 2, and you get 3 over 5, which is the same slope that I got before. So it doesn't matter what 2 points you choose, as long as you reduce the fraction all the way, you will get the slope. So the slope of this line was 3/5. Okay, moving along. Sometimes you're just given 2 points. Okay, here's my slope. So if you were just starting out and you had only known what I just told you, you would go to a graph, you would plot these 2 points, and you would find their rise to their run. You would say, how much do I go up? How much do I go over? But sometimes we ask you to do it when you're not graphing, and that's when we're going to use this formula, which looks very complicated, but not so complicated when you really think about it. So, remember ordered pairs are x, comma, y, and I happen to have 2 points that exist on the same line. So x, comma, y, and this is also x, comma, y. Oops, I used parentheses. That's probably a good idea. So, because I want to tell the difference between this x, comma, y and this x, comma, y, I'm actually going to put a little 1 here and a little 1 here. Those are kind of messy, but I hope that you can see them. And those are the ones that are referred to up here, which are much neater. So now I basically want to figure out what is the change of my y value, because that would be the rise, right? When you rise on a graph, you're talking about a vertical change, and that's referring to the y-axis. So I want to know, what is my change in y? So I take my y, which is 2, and I put a 2, and I subtract y1, which is 6. Okay, so I need to do that problem for the top of my fraction. Then on the bottom of my fraction, I take my x, which is 5, and I subtract my x1, which is -3, double negative there. And now I'm going to actually do this problem. Now remember, the change in the x value is talking about the change along this, the run, which is the change along the horizontal axis, which is the x-axis. And that's why the y change is over the x change. And it's hard to remember that, so make sure that gets starred in your notes to self. So what's 2 minus 6? -4. And 5 minus -3 is actually 5 plus +3, or 8. So the slope of this line is -4/8, or you would say -1 over 2. So the slope is -1/2. Okay, now just to do this very quickly, I could change this up a bit, and I could make this one x and this one y, and this one x1 and this one y1, and it will still work as long as I get my x's and my x1 and my y1 in the same coordinate. So now if I do x, -3, oh excuse me, start with the top, y minus y1, so y is 6, minus y1, which is 2, over x, which is -3, minus x1, which is -5. Now I'm going to actually compute that. 6 minus 2 is 4. -3 minus 5 is 2 negatives together, which is -8. When I reduce 4 over -8, I realize that that's just going to be -1/2 also. Notice how I got the same thing. You don't need to do it twice, you just need to do it one of these 2 ways. Okay, so now here's my cheat sheet up here. This is a very important rule, as I've already told you. If I'm going to compute the slope of, either one of these 2 lines, I have to use one of the 2 methods that I've chosen, that I've just taught you. So let's use the rise over run method for the first one. So I'm going to find 2 points. Looks like here's a point right here, and here's a point right here. And I'm going to say, okay, what's my rise over run? Well, this one I'm not actually rising, I'm actually dropping 2. So I'm not rising, I'm dropping, so that would imply a -2 change. Running to the right implies a positive change, so my positive run is 2. So my rise is -2, my run is 2, so my slope is -2 over 2. Not an acceptable answer because I need to reduce it, so the change is -1. My slope is -1. Notice how it's going in a downward fashion if I read it left to right. This one also is going in a downward fashion if I read it left to right. So it's getting a little bit harder to see, but let's use the points here. This point here is 0, 2, and this point here is 1, 2, 3, 4, 5, 6, 7, 0. Those happen to be the 2 points I'm going to choose. I could use the rise of a run, which personally I prefer, but I'm going to use the y minus y1. And I'm going to make the highlighted my y1 and my x1. Okay, so y is 2 and y1 is 0. That's on the top. My x would be 0 and my x1 would be 7. And now I'm going to compute this slope, and I get 2 minus 0 is 2, 0 minus -7 is -7, and I have -2 sevenths. Probably best written like this for the slope. Okay? Okay, now we've got some kind of weird slopes. So this one I talked about before. If you were a skier trying to ski on this, oops, there's my funny skier. Trying to ski on this, you would say to yourself, gosh, I really am not having a good time doing this because I'm not getting any sort of speed based on the hill. It's just a flat run. It's like as if you were trying to get to the ski lift and there was just no incline whatsoever to help you get there. So we call a horizontal, perfectly horizontal line to have a slope of 0. And that's something that I've just memorized over the years. But if you forgot, you could always compute it. You could say, okay, here's my first point, here's my second point. How many am I rising to travel from here to here? My rise is 0. How many am I running? 3. So my rise over run is 0 over 3, which is 0. I could also calculate using the points. In this case, I'm not going to because that'll take me more time. Okay, any horizontal line will have a slope of 0. Any vertical line, however, if you were a skier, it's hard to draw. You're trying to ski down this hill, and what happens? Splat. Okay, so you're not really able to ski off this hill because it's a sheer cliff. So in mathematical terms, we say that this slope or this line has no slope. Okay, now if I'm actually going to say I forgot that, well, okay, it's hard to remember everything, so let's compute it. I choose 2 points, and I want to know, okay, to travel from this point to this point, how many do I rise? 1, 2, 3, 4. My rise is 4. How many do I run? None. My run is 0. And your antenna should go up when you see a 0 in the denominator because you can never divide by 0. So therefore, if you plug this in your calculator, you'll see it too. This slope is undefined. So no slope or it's undefined. Either one is acceptable. This is our final slide, parallel lines. Parallel lines, when you look at their slopes, you have to determine something very important about them. Well, you're going to compute it in this lesson, but I'm going to give you a little preview. So if I were to compute the slope of this line, I would say, what is my rise and what is my run? So my rise is 1, 2, 3, 4, 5, 6, 7. And my run is 1, 2, 3, 4. So my slope of this line is 7/4. Well, if I go to this line, I'm going to find 2 points. Let's find this one and this one. How many do I go up? 1, 2, 3, 4, 5, 6, 7. How many do I go over? 1, 2, 3, 4. Oh my goodness, the slope of this line is 7/4. So 2 parallel lines are going to always have the same slope. Parallel lines are lines that don't intersect. And the slopes are equal. Okay, and for my final one, I'm looking at 2 perpendicular lines. Well, do you remember what perpendicular lines are? They're 2 lines that intersect at a point that create a right angle, and that's what that box represents. 2 lines that intersect at a 90-degree or right angle. Well, what's the deal with their slope? This one's a little bit different. Notice how this one's positive and this one's negative. So that's the first distinction. But now if I actually put a number to it, let's see what I get. Okay, so the point here and the point here. So I rise 2, run 1. So the slope of this line is 2 over 1, or 2. You could just say it's 2. But let's keep it as 2 over 1 for now. The slope of this line is, all right, here's 1 point and here's another point. How many do I rise? Well, I actually drop 1 and I run 2. So the slope of this line is negative 1 over 2. So this is the slope of this line. This is the slope of this line. So if we can conclude that the slopes are opposite signs, one's positive and one's negative, and they're also reciprocal. This is 1/2, this is 2 over 1. Opposites and reciprocals. Again, this is a preview for what you're going to see in the lesson, or perhaps you're watching this at the end of the lesson to write your note to self, so it should ring a bell. But these are really important facts to have in your notes to self because it's something that you may forget in the future and you want to be able to remind yourself. Good luck!